Hello, I'm Chris Holland, and this is shit you could have Googled in 30 seconds. Today we ask, can a kaiju exist? To be specific, we are focusing on Daikaiju, the behemoths traditionally seen in such films as Godzilla, Pacific Rim, and Cloverfield. Kaiju technically just means monster, but in our current vernacular, it has become equated with Daikaiju, monsters weighing in at thousands of tons, toppling buildings and swatting down helicopters. So for the sake of simplicity, I'll just be using the term kaiju. To get to kaiju, we need to look at the zoological spectrum and deconstruct morphology for kaiju potential. So let's start with some of the oldest creatures, insects. In movies such as Them and Mothra, we've seen arthropods grown to kaiju proportions. But is this possible? Starting from the outside in, we need to address the exoskeleton. Arthropods such as insects and crustaceans have a segmented exoskeleton with all of the soft tissues protected within. Now, if we enlarge an insect, there is a linear increase in height, an exponential increase in surface area, and a dramatic exponential increase in mass. So, as the insect doubles in height, the exoskeleton may quadruple in area while the weight increases 10 times over. This trend continues, so before long, the weight becomes so great that the exoskeleton would need to be at least a meter thick to support it, at which point there is no longer space inside for the musculature required to operate it. Speaking of exoskeletons, to achieve that growth, they would need to molt repeatedly. Molting leaves them soft and vulnerable until they form the new exoskeleton. A tiny insect may be able to hide in tree bark for the duration, but as it gets larger, predators will take notice of a juicy, boneless giant bug. So the chances of reaching adulthood drop considerably. Insects also have very different circulatory and respiratory systems than we do. They breathe through tiny tubes on the outside of their body called trachea. The larger an insect is, the more trachea it needs to meet its oxygen needs. At some point, because of the exponential increase in metabolism, it would need more trachea than it has available surface area for them to be on. And as for the blood, they have an open circulatory system lacking blood vessels or arteries, so the gravity would pull their blood downwards in their bodies, hampering oxygen metabolism even further. So clearly, insects are not a good starting point for a kaiju. One of the considerations regarding kaiju is Bergmann's rule, a well-known ecogeographic trend of larger body mass in cooler habitats. It reflects physiological adaptations to prevent heat loss because large animals have a reduced surface to volume ratio. We see this in the current largest animal on the planet, the blue whale. The blue whale can reach as much as 100 feet in length and weighing in at 190 tons, but its buoyancy gives it an advantage over kaiju in that it doesn't need to support itself. The weight of the whale is actually a necessary component of survival, retaining body heat in the cold water. As with all aquatic mammals, they increased mass to survive, but this also resulted in an increased metabolism. Their method of baleen filtration to eat is as efficient a method as possible, but eating constantly, they cannot grow any further. Additionally, they cannot grow into kaiju because of their mass. If they go on land to attack skyscrapers and screaming, badly dubbed public, they would suffocate because their bodies cannot support their own breathing. So, we need to pivot our search to land animals. And an obvious choice would be the legendary thunder lizards, the dinosaurs. Being some of the largest creatures to ever roam the earth, they are a proof of concept for a kaiju. Everyone loves Sue, the largest Tyrannosaurus rex ever found. She stands at 40 feet tall at the Field Museum in Chicago. She would have weighed about 10 tons before she died beside a riverbed some 67 million years ago. But as terrifying and photogenic as the T-Rex was, it was not the largest dinosaur. That award goes to a sauropod known as the Meronopinosaurus fragilis, dwarfing Sue with a length of 200 feet and a mass of 150 tons. Of course, with the mass extinction, the stage was set for mammals to take the crown. In the Cenozoic era, we saw mammals' body mass rapidly multiply, increasing by 3 orders of magnitude by the late Eocene epoch. Some of the largest include several Dinotherium, such as mammoths and mastodons, but the largest land mammal ever was the Paracitherium, a hornless rhinoceros that stood 18 feet high at the shoulder and weighed 30 tons. So, armed with that knowledge, it seems our kaiju would be some sort of lizard, mammal, or dinosaur. Lizards would be cold-blooded, mammals warm-blooded, and recent research suggests larger dinosaurs were also warm-blooded. Each option has its challenges. A warm-blooded kaiju, at 7,000 tons, would need to eat anywhere between 170 to 314 people per day, depending on digestive efficiency. That's just crunching the calories in a human. It would produce 40 barrels of urine per day and reproduce singular offspring once every few years. On the other hand, if it were cold-blooded, it would only need to eat 13 people per day, but before you get too excited, it would have a litter numbering millions. And this is where the biology really kind of breaks down, is temperature regulation. If it were cold-blooded, then the kaiju would have to sunbathe continuously without night to maintain a metabolism because the warmth would have to permeate meters of epidermal tissue. If the kaiju was warm-blooded, then internal temperatures would reach in excess of 300 degrees Fahrenheit, cooking it from the inside because there isn't enough surface area to vent off the core temperature. Additionally, the kaiju would be brain dead because the heart could not physically pump blood all the way to the brain. To do so, the heart would have to fill the entire chest cavity, and blood vessels would have to be large enough to drive a car through. At that point, there's no room left for other organs. Speaking of the brain, nerve signals move at about 100 meters per second in humans, fast enough that we don't notice it. But for a kaiju, hundreds of feet tall, the nerve signals for movement and sensation would take a few seconds from brain to foot. Between sensing the surroundings to anticipating foot placement and then the delayed response of the signals to actually move the foot, the kaiju would be moving in what we perceive as extreme slow motion. Paleontologist Mike Habib, when interviewed about Godzilla, estimated the maximum size an upright land animal could survivably reach is about 80 feet, far below the threshold that we envision as a Daikaiju, and 1/5 of the current Godzilla's height. If we were to ponder the actual existence of 80-foot monsters hidden on some remote island, we have one more hurdle to address, the same one faced by cryptozoologists every day. And that's minimum viable population. MVP is the smallest population size a species that has enough genetic diversity to survive in the wild. 500 to 1,000 individuals is considered the MVP for terrestrial vertebrates, but that fails to account for inbreeding. When we take into account the dropped alleles and genetic drift associated with inbreeding, the minimum viable population jumps to a few thousand. Even if they were 80 foot tall and hiding at the bottom of the ocean, you'd think just one would have turned up by now. I want to thank everyone for watching, and if you enjoyed this video, please hit like and subscribe if you aren't already a subscriber. You'll find the resources and links for this video in the description.